So tokenization, as I was talking about, yeah, this is one of the life cycle diagrams. You can see how you can add tokenization and masking to your Hadoop-based data ingestion and data query workflow. And it's not just Hadoop, it can be any data lake. We're going to showcase Hadoop as one of the possible integration there. And it provides a couple of things here, the whole integration. One is the ability to tokenize. So basically you can have data in a format which is still have the same format. For example, if you're talking about a credit card number, the tokenized credit card number still looks like some credit card, but it's not the original one. So your analyst can actually work with it and do some analysis around it, but you're still not sharing the data. And so ability to tokenize in a performant way, we do format preserving tokenization using FF1 algorithm, and FF1 allows you to do tokenization without actually saving the tokenized data. So you don't have to worry about the size of the data, or you can do millions and billions of rows without affecting the performance. The second aspect is role-based access. So you can actually, because self-referring KMS provides different roles to different users when you log in on self-referring KMS UI or dashboard. You can also pass those roles to actual applications. So applications who do not have role to see the original data, they won't be able to see the original data. So you can work it out with the Hadoop access control and make sure the right people have the right access. Again, tokenization happening inside the HSM, inside key management systems. None of the keys that are driving this tokenization is revealed outside. It is fully integrated. We have utilities that can help you integrate end to end, which can be very transparent to the end application. The deployment is easy because of the modern GUI that we have, and REST API makes everything possible here. Yeah. So I think that there are two aspects of it still that you can see here. One is you can tokenize the data while saving in your data lake. So whenever you are saving things in your Hadoop file system, you can tokenize and keep it so that you're not saving the original data and only the tokenized data. So here you can see the workflow over here, that when the data is actually being pushed into your data lake, it first talks to self-referring KMS to protect the data. The second way is you can keep the original data in your data lake, but the querying facility, which can be Hive or some other kind of querying mechanism, and you can inject the ability to do role-based access and tokenize on the fly, so that the people who have lesser privileges for the data, they're not seeing the original data, they're seeing the redacted one, or they're seeing the tokenized data. So we'll see the both of the ways in the demo. Okay. Just okay. I'll just see if I can. Okay. I hope this is visible. I'm trying to full screen this. Okay. Let me run this from my local, so that is much better. Okay. So this is one of the recorded demo that we have, but it gives you the end-to-end understanding of what is required to make this run. The first thing is you go to your self-defending KMS dashboard, and your administrator must have already given you a user to log in and work as administrator in terms of creating the right keys, creating the right access, so that it gets integrated and with your tokenization, your data lake-based systems. So let's log in as some user. What we're doing here is, once you log in, self-referring KMS is primarily a multi-tenant kind of system, so you can have different accounts. So this showcases that you're working with one of the accounts that have been assigned to you. Once you select your account, this is a dashboard that you see over here. And this dashboard allows you to have a bird's eye view of what's happening in terms of key management across your account. So security objects that you see here means actually the keys. Keys are named as security objects. Apps are a way to integrate with your application. Plugins are custom code execution that you do, and you have a nice dashboard and a graph here on the usage of the keys when the keys were being used a lot. What this showcase is, you have a concept of groups. Groups are a way to to segregate different kind of keys based on business use case or projects or ownership. So what he's showing in the graph here is what is the actual use of the groups across the period of time, which group is being used a lot in terms of access of the key or crypto operations and other things. So you can have a nice reporting. Moving ahead from here, um, we'll find the right group where I have saved a key that will help us to do tokenization. So you can reach the group by the sidebar as well. Once I select my group, there are a lot of information you can see in terms of what you can do in the group. There are a set of policies. If you see, there's a quorum approval policy, cryptographic policies. So group level, you can set a lot of policies around what kind of keys are allowed for any sensitive operation. Does it require some kind of key ceremony? That's quorum approval policy. And all the security objects, which is keys, reside as part of this group. I'm just taking a look at the users. Also, you have a role-based access, which we talked about. So this particular group has 4 different users. The current user I've logged in, which is Sham Smith over here, is an administrator in the group. So it has higher privileges of doing things in this particular group. Apps is a general way to integrate your current applications or do automation around the group. So you can think of this kind of a service account in this particular group that helps you do crypto operations or create keys or manage keys in some sense. So if you're integrating with your database, with Hadoop, this app this app entity will help you decide the authentication mechanism. Right now, if you see, it says copy API key. So we are using API key, or you can think about as a token-based authentication. Once you share it with your application owner, they can actually authenticate to self-defining KMS and work with the keys, which is part of the same group. These are some of the keys or security objects as part of this group. You can also notice there are some secrets as well. So we'll look into secrets in a different demo. But if we look at the type over here, we'll find the type of the keys, which is AES, RSA, in fact, elliptic curve keys as well. And using this particular key to do the tokenization. Okay, I'm trying to showcase here that how to create a new key that will help you allow do tokenization. So um, yeah, so this is okay. So let me pause here. I think there's always a question about what is the difference between encryption and tokenization. So the next steps that showcase actually an encryption, and we'll compare with tokenization to see what is the actual difference between these two these two operations, and which operation will help you more in your use case. So we're creating an AES key which is meant to do encryption, and you can see the details of the key, who is created, what are the key operations, what are the operations permitted. This is a general detailed view of a security object. And this can be the encryption key, this can be the tokenization key, where you see all these details. You can copy the ID of the key. This ID is the unique ID of the key. Okay, let's go to plugins. And again, plugins are also part of the same group. And we're going to showcase the 2 plugins execution that allows you to do tokenization and encryption. Just to note, plugins are not the only way to achieve tokenization. You can achieve tokenization is a native feature, so you can use REST APIs or one of our client libraries to achieve tokenization or encryption. Plugins just allows us to showcase things in a real-time way on this GUI. So let's go with non-tokenization, which is an encryption use case. And what I'm going to do is I'm taking an input data, which is hello world, and I'm going to actually encrypt with an AES key. So this is an encryption, which is a standard AES encryption that typically is done in cryptography. And I hope it's visible, but there's some output about what happens when the encryption is done. And cipher, if you can notice over here, is actually the encrypted value of the key. And if you note the cipher format, for all the purpose, it's kind of a random bytes that you're working with. And that's what happened in encryption. It can be a readable string as an input, but whatever its output is, it can look as random bytes, and there's no format attached to it. So this is the when you do an encryption of hello world. Let's try to decrypt it back. So I'm using the plugin. Plugin also allows us to decrypt things back. And I think what I'm doing here is I'm just changing the key, and the plugins fails. So I cannot decrypt it with a different key. I need to pass on the same key, and that's what it's showcasing here. If I fix the ID of the key, I get the original data back, if you see here. So you have an AES key, you did the encryption operation, you got the cipher. If you pass the cipher back to decryption operation, you got the original data back. And this is what encryption is. And let's try to understand what's difference in tokenization here. I'm going to plugins again, and on this time you're choosing the tokenization plugin. And yeah, this is a plugin over the native APIs that helps you do something more, which is tokenize IP addresses. So if you see here, I'm trying to do a tokenization of the data. And again, I'm using some AES key to do tokenization. And if you see the output over here, if you see clearly, look into data, it's actually the last the last octet the last set of the IP address is actually different from the original one. And what it's saying is, if you see the input, which keep equal to 3, it says I want to tokenize, or I want to change the format, keeping the format same. I want to change it to a different data, but I want to keep the first 3 set of IP components same. The last component is different. So that's why only the change is the last component here. And if I pass the new data back again and try to detokenize, you'll get the same thing back. And I can do keep 1, which means I want to only keep the first component same and the next 3 component different. So if you see here, it's 12, 150, 59, 62, which is different. And if I pass the output, this is the output was the tokenization. I'm now detokenizing it, and the operation is reveal, which is detokenization. If I do it back, I get this original IP address back again. So if you try to understand encryption versus tokenization, encryption is much more, I think, secure, because it converts an input into a totally non-understandable output. But if you're trying to do data analysis, and if you're trying to integrate with legacy data systems which does not understand random bytes, tokenization helps to keep the same format but still unrecognizable data, and that's what tokenization brings. So this is what we are testing and showcasing as the native functionality. I think the next thing is how you can bring all these functionality as a process to an existing workflow, and we're going to showcase Hadoop as the workflow there. Yeah, so this is another group I have created for my Hadoop data protection. Yeah, so it has also some of the apps that will use the API key from here in the Hadoop demo later on. If you see for Hadoop demo, we have kept some tokenization keys. If you see here, these keys have different policies attached to it in terms of what kind of data I'm going to see for tokenization. So if you see the keep zip, this is a tokenization key which helps you to tokenize zip zip code values. So it needs to have that policy to understand what is the input data I'm going to see and what you require. Do you want to change? Is the input data alphanumeric or numeric? And so that it can actually keep the formats in the same way when it's actually tokenizing it. So we have 3 different keys for zip, for IP address, for SSN number over here. Okay, so I'm here coming to my actual Hadoop system. So let's see, how we can see this in actually practice in real world. I'm signing into my Hadoop system. There are some of the scripts that I have that helps us to create some sample data and do stuff. So this is a sample script I'm running where I'm just generating some random data, which can be thought as a PII data or sensitive data. So some names, some SSN numbers, some addresses, city, zip code, IP address, email, and date of birth. So think of it as my input data for Hadoop ingestion. I'm putting all this data in my HDFS. So now all the data is there in my HDFS, which is all the customer data. What I'm going to do next is I'm going to work with this data and tokenize it and showcase that tokenized data can be kept in HDFS as well. So I'm trying to protect the data with masking. Docs is the same as the HDFS docs. That is the folder we have given so that every data inside that folder should get masked. And I provided a field called unstructured masking to tell the utility to that my data is unstructured. So do the best case masking of the data there. So it looks into HDFS original input data. It will do the masking. It will do the map reduce through the masking and output a new set of data which have everything heavily redacted. So let's take a look. You see the unstructured data now here. Let's take a look at one of the file. And if you take a look over here, we have actually redacted, all of the sensitive information using the tokenization feature, and we have kept the redacted set of data over here. And you may want to do that so that you have 2 sets of data. One is redacted, one is not, and you can use your role-based access to give more access to the redacted data, but less access to the original data. So this is a way you can tokenize data on the fly. Yeah. So earlier thing was masking, where I want to do redacting. The next second set of data set that you want to build is actually tokenized data, which is not masking, which replaces data with something else, which is similar format, but it's not the original data. So this is what we are doing there. And yeah, so this will look at the original data and find out the PII data, replace it, call SDKMS to do tokenization, replace it, and save it as a new set of data, which is you can see as protected docs over here. Let's see what it contains. If you see over here, there are information, but these are actually modified. If you see the date of birth is modified. So the format is same, but the data is actually very different. And this can be very helpful in your, when your analysts are working on things. They don't want to see the actual data, but let's say they want to do some anonymized analysis. They just need some kind of data which is same across the rows of the data. So what we showcase is you can work with your Hadoop ingestion pipeline, and with the unprotected set of data, you can keep copies of data very easily, which is either masked or either tokenized. Yeah, let's go to the next set of things. So there's another aspect of it where instead of changing the data ingestion time, you can change the data served to the customer during the query time. So again, I'm trying to create some new set of sample data. Yeah, so this is more structured, if you say. And just regenerate again so that I get more random values. Um, yeah, but this is the sample data created. I'm putting this as a HDFS folder called table. Okay, I think we're still going out with the previous demo where we are actually doing tokenization or masking of the structured data. So that's additional to the previous thing. It's more structured data, and you can mask and tokenize structured data as well. These are some sample output that we get for purpose of demo. You won't see all these information there when it actually runs the utility. Yeah. So now what we're doing is we're trying to access. Uh, yeah. So if you try to take a look here, we're trying to access or query all this kind of information using Hive. And for this demo, we have done three things. First thing is we kept data as three different versions. One is confidential data. It has all the original data. Second is actually enterprise protected version, and third is freely shared mask version. And you can use the R-based role-based access of Hive itself because you know the freely shared masks is all redacted, nothing sensitive. I can share it to anybody. But enterprise protected is something which is not fully redacted, but it has tokenized data, so I can give to some set of people. So if you see the guidance over here, confidential expose.csv is top secret. Only few people should have access to it. Enterprise protected should be for an analyst and people with management access. But freely shared data can be shared with anybody, help desk, customer success, customer service team, because it does not have any personal information. So, because of the Protect FF1 utility, we are able to keep three different versions of data, and you can assign role-based access that hides. So let's take a look. Yeah, I'm configuring my Hive to have the right set of role-based access. And here, let's say, for example, I have these many roles. And here, based on these roles, I've defined that which role has access to what kind of data file. So this is what I've set up over here. Yeah. Okay, so let's try to log in as a, I think, help desk person over here. So Sean is a help desk person, and I'm trying to query the table. And whatever I'm getting is just the redacted data, because that's the way we have set up the role-based access. I cannot see the original data at all. These are the next set of things. So I log in as Rich, who is, I think, analyst or a DevOps person who may have higher access to the data. And what we're showcasing here is he still may not get access to the data unless he have this authentication token to self-defending KMS. So that is the you go to self-defending KMS UI, you share the token over there. Only when they have access to this API key, they can look into the data, which is again tokenized. So level 2 clearance of the data you can see here. This is still not original data, but it's still formatted um, and to be worked as a an anonymous analysis. Um, and then you can query confidential data with level 3 clearance that you have as role-based access. So this is one demo that we're running to do some queries around as an analyst. So yeah. Okay, I think we're almost done there. I think it's just going in the loop there. So here you can see the original data if you have the L3 clearance that you see. So what we have done here in summary is that so Hive comes with its own role-based access based on what role somebody has given. And we can overall on top of that you can add another set of access through self-defending KMS API keys or apps. So even if you have access through Hive, you still need this API key that you see here to get access, and you can do automation around it. You can revoke these API keys if you don't, if you want, you can change the role the access to this API key from the self-defending dashboard. And this way, you can protect your data while putting things into your data lake and while querying from the data lake. Yeah, this completes the tokenization aspect that we wanted to talk about.